simplify cosine of inverse sine of x. So here we will let theta represent inverse sine of x. Now if theta represents inverse sine of x, that means sine of theta equals x. So let's pull up our triangle. If this is theta, if sine of theta is x, that's opposite over hypotenuse. And so that'll be x over 1. We need to find the adjacent side. We can use the Pythagorean theorem. But we've already seen a triangle where the hypotenuse was 1 and one of the sides was x. In that case, it was this one that was x, but it doesn't actually matter. If the hypotenuse is 1 and one of the legs is x, the other one is going to be the square root of 1 minus x squared. And so we need to find cosine of theta here, and that is adjacent over hypotenuse. And so that's going to be the square root of 1 minus x squared over 1. But when we divide by 1, that gives us the same thing. So this is going to be the square root of 1 minus x squared. And that is our composition of functions. And interestingly, that is exactly what we got in the last problem when we looked at sine of inverse cosine of x. That is also equal to the square root of 1 minus x squared. So that means that sine of inverse cosine of x is equal to cosine of inverse sine of x, which is quite interesting.